Okay, let's look at how to do some stuff on the graphing calculator for quadratics. So here we go. Let's say I have a generic basic old quadratic. So let's go with 2x squared minus 5x plus, I don't know, 4. Let's see what that looks like. And let's see what that looks like if, actually we can cover the first thing. If your window looks weird or not, standard, go zoom 6, zoom standard. And that'll take your window back to normal. And lo and behold, look, there's our parabola. So a couple things we can do would be because we've looked at features of parabolas, the things that we really sort of care about are things like x-intercepts and finding the vertex. And the graphing calculator has a procedure for both of those, and it's when you press second function, trace, and that gives us the calculate menu. So let's look for the minimum first, or the vertex. And the reason, so we've got value, 0, min, max, intersect. Those are all valuable to us in grade 10 math. So looking for, the reason I'm going to choose the minimum instead of the maximum is because my parabola has a minimum value, right? Because it's the lowest, it's a bottom. So I'm looking for the minimum value rather than the maximum value. If I had a parabola that looked like a hill where it was opening down and it had a bit of a hump to it, then I would be looking for a maximum. But here we go, we're going to look for a minimum. So in doing that procedure, the first thing the calculator is going to ask me is a left bound. In other words, give the calculator a marker that's on the left of where you think your vertex is. So if I look at my vertexes here, I want to choose a marker that's to the left of it. It doesn't have to be far, right? I can get pretty close as long as I'm to the left of it. And I'm going to press enter. Then it's going to ask me for the right bound. So if that's roughly where my vertex is, I'm going to make sure that I'm on the right side of it. And enter. Now it's going to ask me first a third thing, and that's a guess. In other words, tell the calculator where I think my vertex is, or where I think the thing I'm looking for is, between the two markers that I've just created. So my cursor, I'm just going to move it anywhere. All I have to do is move it anywhere between the two, and I'm set. So for me, all I really did here is just move it over one space. When I press enter, the calculator does some thinking, and it gives me the minimum value. So in this case, the coordinates of the vertex are 1.25 and 0.875. Those are the coordinates of the vertex. Okay? Now, I'm going to change my equation a little bit, and I'm going to make my graph look like this. Now I've got something a little more interesting where now I can actually look for some x-intercepts. Before, when my parabola was opening up above the x-axis, I didn't have any x-intercepts. It wasn't crossing the x-axis anywhere, so I can't really find any x-intercepts. But this one, I can. So now I'm going to do the same thing. I'm going to look at my calculate menu and look at the different things I can find. And I'm going to look for a 0. Now the thing you need to be aware of is how many different zeros you have. It depends on your curve, right? A line only has 1 0, but parabolas have 2. So I'm going to decide to look for, and I can choose which one I want to look for. I'm going to look for this one for, actually we've looked at this, we've done this before where we look for this one first. So I'm going to look for this one first. Again, same thing, asking for a left bound. So if I think my x-intercept is here, I want to make sure I'm on the left part of the curve, which right now my cursor is. So I'm just going to leave that there as is. So I've selected my left bound. Now my right bound means I need to, if that's where I think my vertex or my x-intercept is, I'm going to go to the right of it. Enter. And then I'm going to move somewhere in the middle. And I'm going to guess. And there's my x-intercept. Notice that the x-intercept has a y value of 0. Right? Some of you might see that thing where it's like 2 and then a capital E12 or E minus 12. We can treat that as 0. That's essentially 0.12 zeros, so an extremely small decimal. And we can assume that the calculator just wasn't precise enough, and it didn't give us 0, but it gave us something pretty close to 0. So this is a nice answer for me because my y value is 0, and I know that that means I'm on an x-intercept, and the x value is 0.64. Good. Now I'm going to find the other one. So 0. Now it's going to ask me for the left bound, so I need to click over and go to the left side of the curve, and I am. Then I need to go to the right side of the curve, and I am. And then I need to go somewhere in between. And there's my, here, good, here's an example. So -1 e to the minus 12. That's an exceedingly small number, and we're going to basically say, well, we'll call that 0 because it's so bloody tiny. But my x value is -3.1. So -1, -2, -3.1. So that's not a bad approximation. Now, one thing, we'll leave the same curve. So one thing that some people are doing when they're trying to find zeros and max min is they're actually, rather than doing the calculate menu and finding it very accurately, some of you are just going trace and trying to find it, right? And yeah, you're gonna get a value that's pretty close, but like we're not right on. We're a little bit below. And remember, our number was -3. Like I don't think it was 19. It was a bit smaller. We're getting into the realm of inaccuracy, and I know that in the real context of things it doesn't really matter, but in math we want to try and be as precise as possible. So yes, trace is a good tool to use. You can click around and get close to where something might be, but it's not going to be as accurate. And in terms of a graphing calculator, if we have a tool that's going to give us an accurate answer, let's use it. If we're going to otherwise we're just going to do everything by algebra, and I want to give you more than one tool. So graphing calculator, if we're given a tool to be able to find the exact coordinates or pretty darn close exact coordinates of things like a vertex or x-intercepts, well, we may as well use those. Because trace, yes, it's an approximation, but again, we're after precision. So I guess that's all I really have to show you in terms of using the 0, max, and min part. Oh, value. So value is something that you can ask the calculator. If you give it an x value, it's going to tell you what its y part is. So if I want to say, let's see what the y value is when x is 0, in other words, the y-intercept, what I'm looking for is if x is 0, I'm asking the calculator to tell me what the y value is. And it looks like we're probably going to be somewhere 1, 2, 3, I guess 4. So that's what the value function does. Now if I had asked the calculator for, let's say, -2, well, -1, -2, the y value is somewhere up here, maybe 4 point something, 5 perhaps. 6, a little bit higher. So that's what the value function does. All it does is give you the y value if you decide that you want to plug in an x value, hence I guess they call it the command value. If you pick a specific x value, it gives you the y part. So you don't actually have to do the solving an equation by hand if you don't want to. Well, there you go. For the quadratics unit, there's 4 tricks that you have: value, 0, max, min. Goodbye.